Hey guys, how's it going? So we're going over the imaginary number classwork here. So we have already covered some of these questions in class. However, if you're watching this video on perhaps Tuesday night, Wednesday night, you might not have gone over all these questions in class, so that's okay. I will go over how to do them when we go in class together. But I want to get this video done, make sure you have the entire thing available to you. So let's knock it out. So one of the key ideas to remember while doing this, we have a couple big ones. One of them, your answer must be an A plus BI format. So I'm looking for an A and a B. And the reason why, again, is because eventually in higher level math, you will be writing that as a coordinate. So you must have the A and the B in every single answer. In addition, one of the key simplifying ideas that you're going to go through here is that we know that I squared is -1, I cubed is -I, and I to the fourth is back to 1. So we're going to be using these ideas throughout the entire thing. To start off, though, we're quite literally just adding like terms. The -7 and the -7 become -14, and then -8i. Starting off with a freebie, really not much to it, but we are in that A plus BI format. -14 first, then the -8 afterwards, ending with 8. Continuing on, we have 5, -7, -8. All of these guys are like terms. 5 minus 7 is -2. -2 minus 8 is -10 with the I, but remember it's A plus BI, so the 1 must go first. That's it. This next one, I actually have two acceptable answers. For number 3, we're going to multiply 5 times 8. We're going to get -40 with the I, but you got to remember, while that's an acceptable answer, the perfect answer puts it into A plus BI format, so you include the 0 in your answer to say it's 0 for the real part, -40 for the imaginary part. Very, very cool, very useful. Let's continue on. So for this particular question, number 4, we have 3i times 4i times 6 minus 5i. I believe it's best to start multiplying these two. However, you could distribute the 4i first. It doesn't actually matter. I think this is easier though. You'll get 12i squared times 6 minus 5i. And from above that we wrote down, one of the things we wrote down is that big one, I squared is equal to -1. Because I squared is equal to -1, that's 12 times -1 times 6 minus 5i. And 12 times -1 is -12. And finally, we have our distributive property. We can distribute the -12 to our 6 and the -12 to our -5, and we'll get -72 plus 60i, and that's it. We're in A plus BI format. We're all done. Keep the ball rolling. On number 5, we're going back to a review. It's the idea of distributive property. We're distributing our 7 to both, our -5 to both. I'm going to pause the video really quick to get a drink of water. All right, we're back. And here we go. So we're distributing that 7 to both, distributing the -5 to both, and we're going to get 21. 7 times -8 is -56i. Don't forget, you can use a calculator for any part of this. Do not be afraid. There's nothing wrong with using a calculator for these. And you get +40i squared. So while you're simplifying this, some of it simplifying is nice and obvious. So for instance, there's -56i and -15i. These guys are just like terms, so we can combine them up. If you do combine them up, we'll get -71i. But this +40i squared, that I squared again is that -1. So this is going to be +40 times -1, which is really just -40. And 21 minus 40, that's going to be -19, and then minus that 71i. I said 71 and I wrote 70. It's a 71. A really bad 71, but a 71 nonetheless. Keep the ball rolling. On this one, you got to be a little careful. Got to remember our rule when you have a negative out in front that it distributes. So we have 2 minus 3i minus 6 plus 8i. And then we're just adding those like terms. 2 minus 6 is -4. -3 plus 8 is +5i. keeping it moving. Same idea that negative needs to be distributed. It's just practice. Plus 7 plus I minus I, positive I minus I. Those guys can cancel out nice and easy. And then it's just 7 and 2 added together gives you a 9 plus 4I. Beautiful. Number 8. Oh, I'm getting called down to dinner. Pause the video. Okay, so I'm back. It's been quite a bit of time for me, but no time for you has passed. I went and had a Taco Tuesday here. Mom made tacos. They were delicious. And now we are back to doing these problems. So continue on. This is very similar to that previous question. We're just going to multiply together. So if we do 2I times negative I, we get negative 2I squared. However, I squared, as we discussed earlier, is equal to negative 1. And negative 2 times negative 1 is positive 2. I did request A plus BI answers for all of these. So 2 plus 0I is what we're looking for. However, if you did answer just 2, I'd probably still give you full credit. But remember, you're going to eventually be trying to answer these I questions and coordinates in higher level math. So try to make sure you're doing that every single time. All right, continue on to this number 9. So in this problem number 9, we are going to take this negative. We're going to be distributing both of those. And then we just have a whole boatload of like terms after that. So there's the 7 plus 2I minus 1 plus 8I, and then tons and tons of like terms. So sometimes there's a lot of like terms. I like to do underlining for the real parts, and then maybe no underlining for the other parts there. So we have negative 1 plus 7 minus 1. That's going to be 5. And then here we have 7I, 2I, and 8I. That altogether is going to be 17. A plus BI form, and we're all done. For number 10, more the same idea, taking that negative and distributing it. So we have negative 3I minus 4 minus 8I. Negative 4 comes first. Combine those like terms, negative 11I. Easy enough. Let's keep moving on to number 11. So number 11 is a little bit of a mean question. You have to distribute, get those like terms together, and then you got to distribute again. So you have to do all of it twice. A little bit annoying, but still ultimately doable. So negative 5 times negative 8 is going to be 40. Like that. And then negative 5 times negative 7I is plus 35I. We're doing our first outer, and now our inner minus 16I, and our last minus 14I squared. Remember, all this is going to be multiplied by 6 plus 5I later. Adding our like terms up, we got 40, 35 minus 16. 35 minus 16, that's 25 minus 6, which is 19I, and minus 14I squared. Because I squared is negative 1, that's going to be plus 14 here. Still times 6 plus 5I. And now we have to go ahead and add our like terms. We get 54 plus 19I multiplied by 6 plus 5I. And now let's repeat the process. Another first, outer, inner, last. So 54 multiplied by 6, that's going to be, what's that, 324. And then our outer, that's going to be 270I. And then 19 times 6, that's going to be 114I. And 19 times 5, that's going to give us that 95I squared. Okay, and now we just need to go ahead and add our like terms and apply our I squared rule. So I squared is negative 1s. This is minus 95. And finally, 324 minus 95. These guys combine together for our like terms. So that's going to be, what is it, 324 minus 100, 224, and add 4 more, 229. So 229 plus 384I. And again, feel free to use a calculator or any part of that, no big deal. Same exact concept on number 12. I recommend taking this negative 4i and distributing it in, or doing our foiling first and then the negative 4. Kind of either one is fine. I think it's easier to do the negative 4i first, though. So negative 4i to both of these, it's going to give us negative 28i times negative 28i squared. And again, still multiplied by negative 6 minus 6i. Then we have this I squared here is turning that into positive 1, so that's plus 28. Now, you could rewrite it in a plus bi form here, but it's not really required. You only have to write an a plus bi form in the final step, so I'm not going to write an a plus bi form for this step. Only in the final step is where that's needed. So now we got negative 28 multiplied by negative 6, and what's that going to be? That's going to be... oh boy, 168. So we have positive 168i. Did I do that right? 120. Yep. Okay. And then distributing out, it's going to give us another. Every single one of these is going to be 168, right? It's 168 across the board. Yep, 168, because every single multiple ends up being 168 in some way, shape, or form. So our outer two here is going to be negative 28 times negative 6i. So two i's there is going to be plus 168 I squared, and then minus 168 here in the center, and then finally 28 times negative 6, so it's going to be minus 168i. So we have 168i, and oh, you can't even read what I wrote. Negative 168i, those guys end up canceling out. I squared is negative 1, so this is negative 168 minus 168. And there are no i's left. We will write an I in our very final answer, and adding those together, that's negative 330. So negative 336 plus 0i. Interestingly enough, 0 i's out of all that. All the i's at the start and no i's at the end. I guess they all ended up canceling out. So continuing on, number 13. So this is where things change up a little bit. Honestly, we do have a little bit more work to do on these, and that's okay. We just got to do it. So to start off on this question, I'm running out of room, so I'm immediately going to copy it just because I'm running out of room and I don't want to have to mess up. The main concept here was always multiplying by the conjugate. So the conjugate on these questions, if you have a plus bi, the conjugate is a minus bi. And the main reason why this is useful is if you multiply those two guys together, that is to say you have a plus bi, a minus bi, and you multiply them together, it always ends up being a squared plus b squared. So that was a key concept from these problems. In other words, it gets sort of the I. So we're always going to multiply by the conjugate of the denominator, and we're going to multiply it by a version of 1. Negative 9 plus 2i on the top, and negative 9 plus 2i on the bottom. And when you do that, you get 5 multiplied by negative 9. That's going to be negative 45. 5 times 2, you get plus 10i. 9 times 9, negative 81i, and then 9 times 2 is plus 18i squared there, all divided by, and the whole point of doing this on the bottom is you get a squared plus b squared, no i's at all. So negative 9 times negative 9 is 81, and negative 2, or 2 times 2, because you just have the positive version, is 4. Simplifying this up, we have negative 45 right here, and then the 10i minus 71i, and that becomes negative 18 all over 85. Finally, adding up our like terms together, you'll end up with negative, these two guys are like terms, so negative 63. And when we write this, we want a plus bi form. So we're going to divide by 85 here, minus 71 over 85. All right, so you got to write it as two separate fractions, two separate 85s there. It is important to do it that way. That is how you're going to be expected to do it in the future when you have these questions in those higher level math classes. So make sure you do that. There you go. We're going to be doing exactly the same process in all these questions where we multiply the top and bottom by the conjugate to simplify completely and get into a plus bi form. So we are multiplying by -6 minus 8i this time. Again, all you're doing is changing that middle sign on the bottom and multiplying the top and bottom by it. So again, distributive property, 8i times this -6 is -48i. And 8i times -8 is going to be -64i squared. Continuing on here, we have on the bottom a squared plus b squared. So it's going to be 36 plus 64. This one ends up having a little bit of simplification to do because I see all even numbers everywhere. So they will simplify it a little bit. -48i, and then that turns into plus 64, and that divides by 100. When we're writing our final answer, we're going to be writing two separate fractions, 64 over 100 minus 48 over 100i, and we should probably reduce those fractions. You can use your calculator to reduce those fractions or figure out the largest number that goes into both of them. I believe 4 is the largest number that goes into that guy at the top and bottom, so it's going to be 16 over 25 minus, and it looks like 4 is again the largest number that goes into both of those, so that's going to be 12 divided by that same 25 with an I on it. Keep the ball rolling. Number 15 and 17 can be a little bit tricky to some students because they forget that there's that invisible little 0 in front right there. So you're multiplying by the conjugate of that guy, which is going to be 0 plus 7i. So it's like 0 plus 7i over 0 plus 7i. There's your conjugate. Now, technically, though, you don't need the 0 there. Yeah, so you don't really need the 0 because you're just going to be 0 in the end anyways. When you do that, we're going to distribute. The 5 to the 7 is going to be 35i. The 5i to the 7i is plus 35i squared. Continuing on, divided by 0 squared plus 7 squared, which is 49. For this one, we will have a little bit more reduction to do in the end. So the reduction that we end up doing at the end here will be dividing by 7. This is a -35 over 49 plus 35 over 49i. Every single one of those is divisible by 7, so we divide it by 7. Again, feel free to use your calculator to divide nice and neat. -5 over 7 plus -5, or positive 5 over 7i. You don't need that positive sign at all. Technically, there is a faster way to do these. This particular question, you could have multiplied the top and bottom by just I itself. However, I do think kind of doing the same thing over and over can be better. However, just a note that you could have done that question faster by multiplying by I over I alone, which is what we'll be doing in number 17. All right. Number 16 here, our very last full question. I want to remind you guys, if you haven't been practicing these on your own, you've just been copying, this is a great time for you to try on your own completely. So full practice multiplied by 8 minus 7i over 8 minus 7i. Do some distributive property. 3 times 8 is 24. 3 times -7, -21i. -6i times 8 minus 48i. -6 times -7 plus 42i squared, all divided by a squared plus b squared. Finishing this question off, this is like a -42, so we have 24, -21 minus 28, that's going to be -69i minus 42, divided by, got to add these up, that's going to be 113. And to finish it all off, 24 minus 42 is, what's that going to be? -18 over 113 minus 69 over 113i. Nice. To finish it all off, we're going to multiply by that conjugate. That's going to be 0 plus I over 0 plus I, because there's that invisible 0 in front. So that's going to be 9i divided by, in this case, 0 squared plus 1 squared. And that's just going to be 9i by itself. Don't forget, we want an a plus bi format, so 0 plus 9i. That's it. Have a Wonderful rest of your day. Have a wonderful week. Peace out. See you later.